Stereo vision is basically a very intuitive topic. It's come from the human being have two eyes, and therefore the stereo vision is based on that phenomena of human vision. Recovery of shape or depth from two or more images is basically what we do in stereo vision. So when we watch 3D movies, we use polarized glasses, and movie seen without these glasses, we'll see that two images are superimposed over each other. When we wear glasses, filtering of one image from the left eye and filtering of the other image from the right eye, and thereafter we have a capability of fusing these two images, and then we can see 3D. So basically 3D is nothing but just our capability of human vision to watch two images with certain shift and then thereafter filtering, and that produce 3D. So given two images, what we basically do is write a program which gives us the depth of the objects which are in those images from the camera. So the the output generated will be a depth map. Every pixel in depth map will tell that how far that pixel is from the camera. So stereo image are to be rectified along so that we can find a corresponding match from left image to the right image. So these two images must be rectified. We are assuming that we are using those rectified images by default, or the standard data sets which we use are rectified by default. Now we can discuss the basic algorithm which the stereo correspondents use. The algorithm basically have 3 steps for each pixel. That is, first find the epipolar line in the right image, then examine all the pixels in that epipolar line or scan line and pick the best matching pixel or best match, and then apply the triangulation phenomena to that pixel to get the depth out of it. So let me explain these points in detail. How we do that is, we conduct a search for every pixel in the left image to the corresponding pixel in the right image, and that search is based on intensity match. Suppose we have a pixel this figure shows that in the boundary values the pixel matches by one disparity value, and wherein the center pixel matches by 4 disparity values. So this clearly shows that the disparity value of the center pixel is greater than the disparity values of the boundary pixel. This can be visible by these two images. The girl's displacement is maximum as compared to sun and cloud. So displacement or disparity is the same thing. Also, we can conclude from these images that the girl is closer to us in comparison to sun and cloud. So by this we can conclude that disparity in depth are inversely proportional to each other. Since that disparity is inversely proportional to each other, we can also prove it by a process of phenomena called as triangulation, as I mentioned before. And there is a mathematical proof, a simple mathematical proof for the following. The equations are likewise. Here Zp is the depth and D denotes the disparity. However, F and L are focal length of the camera, and L is the baseline. So these values are given. There is a home page which shows the results, for overall existing algorithm and the standard data sets which are used in stereo vision. References are at the end of the slide. Now the question arises how we can say that this pixel matches to the corresponding pixel in the other image best, in the best way. That similarity measure is based on some components, and that component is SSD, SGRAD, AD, or NCC, or there are various other also. These are the common ones. Suppose there is a scan line, consider a scan line, we move from the left image in the same scan line to the right image, and then we are trying to match window by window, and at one point we are getting lowest cost, or we can say that the match is found. So the match is found by the value where the cost is 0, or in simple way I can say that let's say the intensity value is 5 in the left image. If I found the intensity value of 5 in the right image, then the match is found. So yes, of course there are limitations in this method, because there can be many pixels having the same intensity value, as well as the boundaries. We can see that in the left, in the TEDI dataset, that is the left one, the boundary of the TEDI and the other objects are not visible clearly. So this is one limitation. The other limitation is clearly visible in the next one. Next dataset depth map is we are getting a hollow or a gap over this lamp area, which can be clearly seen in the stereo vision image. So are these limitations, can that be fulfilled, or can that be overcome? This is my objective and problem statement. My objective is to evaluate the all existing algorithms, and to be specific, can I develop a filter, gradient guided image filter, which can preserve the edges or the boundaries in the better way, and which can help me minimize the hollows and overall errors in the image. So the methodology which we followed was the input to stereo image pair, apply the improved filtering technique, which is gradient guided image filter, apply the algorithm for cost matching per pixel. Yes, first the images are filtered, then the matching cost is found, then apply some refinement techniques or some smoothness techniques so that the generated output is depth map. So why the gradient guided image filter only? There are other filters like bilateral filters, meridian filters, and weighted filter, guided image filter. But all these pixels have some drawback, like median filter is best in denoising, but still it does not work well for high resolution images. Bilateral filter is simplest one, however the artifacts near edges are not well preserved in this filter. Weighted filter is having a weight attached with every pixel, so it becomes slow. Speed is an issue in this filter. And guided image filter, weighted guided image filter is they have, although their modified version are also there, but they have some constraints or some factors which take care of smoothness also, pixel values also, but nobody take care of the edge flattering issue. So that is to be taken care in the proposed work. Yes, and the proposed filter is having the complexity or the order of running time same as the number of pixels in the image. So these are the datasets which are used to evaluate the algorithm. The TEDI dataset results. The first image shows the stereo image, one of the stereo images. Yes, the left one, and the B, towards the right side, it shows the ground truth, which is generated by the Kinect or the scanners or the laser range cameras. This is not an algorithm generated output. However, the left one, the C part, however the C part generates, shows us the map with the filters, and the D part shows the proposed algorithm results. Coon dataset. Same, the image pair, stereo image is shown, the ground truth is shown, and then the disparity map without filter and the disparity map with the proposed filter. These are my numerical results which are obtained after the experiment. At last, I can conclude that the proposed algorithm is on an average be able to reduce the average error to reduce down from the test pad, which I mentioned that the home page is containing all the existing algorithm results, is having the best value is 3.799%, and I've reduced it to 3.58%. However, the hollows which we were seeing in the scuba dataset was this one, the C part, and I am able to reduce that hollow to quite a bit extent. So my contribution here is a novel approach of depth estimation that is embedded with the new filtering technique, that is gradient guided domain filter, image filter, and the hollows are being quite being removed, and as well as the edges are better preserved, as we can see in this TEDDY dataset, that the object around the TEDDY and the TEDDY itself are being well preserved. So it is visually also clear that the experiment proves to be successful, and I conclude that complete algorithms solution is being developed. Our experiment has reduced the error percentage to 3.58%. Scope of the topic is very vast, as the further topic or the area where the work has to be extended is to work on the real world stereo images or the noisy data. This shows that my publication status. These are the references for further studies or further look into. Thank you.